Okay, so for this part of the project we are going to explain sequences. Sequences is basically when you substitute in a sequence for n to find out what the limit is approaching. For the first problem I'm going to show you, let's take n over n plus 1 and the limit as n is approaching infinity. So basically with the sequences, you want to make a sequence. So keep basically substituting in a sequence for n. So we'll substitute 1, 2, 3, 4, and 5 in for n and see what the pattern is. You get 1 over 1 plus 1, 2 over 2 plus 1, 3 over 3 plus 1, 4 over 4 plus 1, and 5 over 5 plus 1. These values translate to 0.5, 2/3, 3/4, 4/5, and 5/6. As you can see, the values keep getting greater and greater, but the value will never be 1 because no matter what you substitute in for n, the numerator will never be equal or greater than the denominator. To test this, we'll put in a very large number. For example, 1 million. When n is 1 million, it's equal to 1 million over 1 million plus 1, which, although it's very, very, very close to 1, it will never actually reach 1. So by doing this and using the sequences, we can see that the limit as n approaches infinity, will equal 1. Okay, to show you another example of sequences, we use another problem as 1 over n squared. Now, to solve this, we're going to make a sequence just like in the last one. You can use any numbers you want, for example like 10, 11, and 12, but the bigger the number, the harder it's going to be. So 1, 2, 3, 4, 5, etc. is the best method since they're smaller numbers and they're easier to use. So let's substitute these numbers in the sequence and see what values you get. You get 1 over 1 squared, 1 over 2 squared, 1 over 3 squared, 1 over 4 squared, and 1 over 5 squared. These values translate into 1, 1/4, 1/9, 1/16, and 1/25. As you can see, the values continue to get smaller and smaller. However, they never get negative or equal 0. Now to see what the limit could be like, we'll substitute a very large number in for n. For example, 100. 1 over 100 squared is equivalent to 1 over 10,000. Now, while 1/10,000ths is a very, very, very small number, it is not 0. And the number will never equal 0 since 1 will always be in the numerator. So, we can infer that the limit as n approaches infinity will be 0.